Hello Bit family, this is me Naren. Today I am going to explain about programming designing tool. This programming designing tool helps to design the program. It helps to write the program easily. Following this tool, we can easily design the program that meets the user's need. There are different types of programming designing tool. I'm going to explain only about the three designing tool here: algorithm, flowchart, and pseudocode. Dear friend, if you like this video, please motivate me by liking my videos, subscribe the channel, and please make a comment in my comment section here. First of all, I'm going to say about algorithm. An algorithm is a step-by-step method of solving a problem. Just like if to the robot or to the machine we give some instructions to complete its tasks, the instructions should be given step by step in the same manner, and we can understand the algorithm in the same manner, in the same way. It is commonly used for a data processing, calculation, and other related computer and mathematical operation. An algorithm is also used to manipulate data in various ways, such as inserting a new data item, searching for a particular item, and sorting an item. Here, there are different types of different properties of algorithm. Before writing an algorithm, we should specify the input, and what is the output. We should specify it. Before writing the algorithm, we should specify the output, the result we are getting, and the steps should be of definite. Every step must be taken one after another. Effectiveness, the steps should follow the while writing the algorithm, the steps should go to meet the output, and the steps right while writing the algorithm, the steps should have a finiteness. There should be finite number of steps. If it started, it should have an end, or it should stop. For example, algorithm, I am going to explain the algorithm of two numbers displaying the sum. Start in step 1 we start. In step 2 we declare the variable num1, num2, and the variable sum. In num1 the user will input some number, and in number 2 the user will input another number, and by performing some operation in num1 and num2, adding num1 and num2, the variable, it will be stored in sum. Here in step 3 we read values num1 and num2. User will give some number in num1 and another number in num2, and in step 4 the variable sum stores by adding num1 and num2 variable, and in step 5 it displays the variable sum. Whatever the result it gets, it will display it, and at last it should have it at last in step 6 it stops. Now finding the largest number among the three different numbers entered by the user. Here in step 1 start, I am starting my program. In step 2 I declare the variable a, b, and c, and now from the user I will take some number in a, b, and c, different numbers. In step 4 I am checking if a is greater than b, and if a is greater than c, I will print the number a. The number stored in a will be the largest number, else I am checking that, sorry, this step is wrong. You should not have this step here. Now the second step is if I'm checking the remaining two numbers b and c. If b is greater, I will print the b is the largest number, and if a, b, and c are, a and b are not greatest, obviously c will be the greatest number among a and b and c. And at last in step 5 I will stop my program. Now flowchart, just like algorithm is a step-by-step solution, flowchart is a visual representation of the sequence of steps and decision needed to perform a process. It takes a visual representation. Each steps in the sequence is noted within a diagram shapes. Steps are linked by connecting lines and directional arrows. This allows anyone to view the flowchart and logically follow the process from beginning to end. Here the symbols used in flowcharts are the rectangle shape uses to define the process, and the parallelogram indicates input and output. The diamond shape indicates the decision taken in the program. The circle is used to connect the flowchart, and this shape uses to define subroutine, and the oval shape is used to start and end, and this arrow lines used to show the direction flow of the program. Here examples of flowchart. Here I have given this addition of two number. In this shape I am starting my program, and in parallelogram I read a number A and a number in B. Then I will perform sum operation A plus B and put the value in sum using the parallelogram, using the rectangle, and in I will print my variable sum. Sorry, this I have used here rectangle. I should use here parallelogram. Now using the oval shape I in my program. Here I am explaining the flowchart of two number, finding the greater number of among any two inputted number. Here I have started my program. In the second I take a number in put the value in num1 and another value in num2. Using the diamond shape I check here if num1 is greater than num2, and if it is true I will display that num1 is greater, and if it is false I will display that num2 is greater. Obviously if num1 is not greater, the num2 is greater, and connect uses circle here to connect, and at last I stop my program. Here the differences between flowchart and algorithm are flowchart are block by block information, whereas algorithm is step by step instruction for representing any process of any solution. Flowchart is a pictorial representation, whereas algorithm is a step by step wise analysis of the work. Flowchart is the solution. Is shown in graphical format, whereas algorithm is solutions shown in non-computer language like English. Flowchart is easy to understand, whereas algorithm is somewhat difficult to understand. It is easy to show branching and looping, whereas algorithm has no branching and not looping. It is difficult to show the branching and looping. Flowchart for a big problem is impractical, whereas algorithm can be written for any problem. In flowchart it is difficult to find bug, and if we have to debug the errors, it will be difficult for us, whereas in algorithm it is easy to debug the errors. We can easily modify algorithm. In flowchart it is easy to make flowchart, but it is difficult to write algorithm as compared to flowchart. Now pseudocode. Pseudocode is a rough draft of a program. Pseudocode is an informal way of programming description that does not require any strict programming language syntax or underlying. It does not does not take requires any syntax rules of programming. It summarizes the program's flow but excludes underlying details. System designer writes pseudocode to ensure that programmers understand a software project by requirements and align the code accordingly.